When Wi-Fi 6 came along, it came with the promise of up to 9.6 gigabits per second of Wi-Fi. Now, I don't think anyone's really been able to achieve that except in lab conditions. But it's still a big step up from the 2G and 5G wireless networks that we've used up to this point. Now, if you want to use Wi-Fi 6 on a Raspberry Pi, you could either do it with a Pi 5 and hook a Wi-Fi 6 adapter into the PCI Express port, or you could use one of these, a USB Wi-Fi 6 adapter. Let's go and see how to attach that to the Raspberry Pi. Hello once again, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pis since they first came out, and I wanted to share some of the projects that I've done over the years with you. If you like what you see on this channel, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. And let me know in the comments how you get on with this project. And if you've got any ideas for other projects you'd like to see me do in the future, put those in there as well. Now, in a previous video, I showed you how you could attach a PCI Express network card to the Raspberry Pi 5 in order to get Wi-Fi 6. If you're interested in seeing that, you can take a look right here. It's quite fiddly and it didn't exactly work faultlessly, but it did work out okay and I was able to get those Wi-Fi 6 performance metrics. Now, in theory, using something like this, a USB-based Wi-Fi 6 card, should be much easier to set up on the Raspberry Pi, as it should just be plug and play. Now, as we'll see, it's not quite that simple. The first thing you're going to need for this is obviously the Raspberry Pi itself. Now for this, I'm going to be using a Raspberry Pi 4, but it should work on a Raspberry Pi 5 absolutely no problem. Now, my one and only Raspberry Pi 5 is currently running as my NAS, and I can't quite fit the dongle onto it, so I've not been able to test it on a Pi 5. But when I do get a chance to do so, I'll pin a comment in and let you know of any issues that I hit. Now, the other thing that you're going to need is obviously the Wi-Fi 6 dongle itself. This is the one that I'm using, but do shop around. There's plenty on the market, and they'll all work in pretty much the same way. Now, as you'll see later in this, I do need to grab and build the drivers for it. So if you do get a different model, you may need to search around to find the drivers that support the chipset of your specific dongle. But the actual procedure will be the same, and I'll show you how I went about searching for that later. Now obviously the other things that you'll need for this are a power supply for your Raspberry Pi and an SD card to put the operating system on. But I think most people will have those lying around. So let's go and put all of this together. So the first thing you're going to need is the operating system on your Raspberry Pi. And to install that, I'm going to be using the Raspberry Pi Imager software. Now this is really easy to use and it lets you set up the operating system for your Raspberry Pi. When you run it up, all you have to do is click Choose Device and select the model of Raspberry Pi that you're using. In my case, a Raspberry Pi 4. You then click Choose OS. And here you get a big list of all different operating systems that you could install on your Raspberry Pi for all different use cases. In my case, I'm going to use a specific version of Raspberry Pi OS. I'm not going to use the latest one because Bookworm has a few quirks with it about how it handles its networking and it makes things a lot more complex. So instead, I'm going to come down to Raspberry Pi OS Other and then scroll all the way to the bottom. And I'm going to make use of this legacy 64-bit version of the Raspberry Pi OS. I then just click Choose Storage and I can select my SD card. I then hit Next and it allows us to create settings that can then be applied to the operating system when it gets installed. If you hit Edit Settings, then you get this window pop up that you can see here. It allows you to create username, password for your operating system and also wireless LAN details. Now obviously here I'm having to use my 5G wireless LAN details because we haven't set up the 6G wireless network card yet. But after this, you can just hit Save. Once that window's closed, then you can say, yes, I want to apply those customization settings, and yes, that I want to continue. The OS will then be written to your SD card. It will take a few minutes, so I'll just come back when that's done. Now that's written and verified, I can go ahead and take the SD card and plug that into my Raspberry Pi along with the USB Wi-Fi adapter and then fire it all up. Here I have two sessions on my Raspberry Pi. In the one on the right, I'm going to run a command called dmesg with a ---- follow option. And what this will do is it will show me information about devices connected to the Raspberry Pi. Now I've just temporarily disconnected my USB Wi-Fi adapter so you can see what happens when I plug it in again. What you can see here is that now some new information has appeared talking about my Wi-Fi 6 adapter. Now one thing that's really critical here is this section where it talks about the vendor and the product ID. We'll be making a bit of use of that in a minute, but if I go to this other window and I use the command IP link show, you can see here it only shows the normal devices that you'd expect to have on a Raspberry Pi by default. ETH0 is the wired internet connection, and WLAN 0 is the internal Raspberry Pi Wi-Fi connection. There's no network device shown for our new Wi-Fi 6 dongle. And the reason for this is that there's no driver support natively built into the kernel, and so the Raspberry Pi doesn't actually know how to talk to the device. Now in the other window here where we've got the vendor ID and the product ID, this is showing me that the manufacturer of the chipset of this particular Wi-Fi card is Realtek. Now you can see that a little bit further below, but it's also represented by this vendor ID of 0BDA. For any USB device, it will always be identified by a combination of a vendor ID and a product ID. In this case, the product ID is C832, and we can make use of this information to go off and find the drivers for this particular card. Now what you can see here is I've done a search for 0BDA C832 chipset, and this is what I've got back. And it's telling me that there's something called RTL8832CU. Now when it comes to this Realtek device, this is the ID of the chipset. Now taking that one step further, I then searched for the drivers for that particular chipset. And following the first link that was returned there, I ended up here, where there were download links for a Windows version of the 8832CU drivers for Windows and the 8832A USB drivers for Linux. Now what I found was the 8832A drivers for Linux did not work with my device. And I think the reason for that is back here in the product ID, where mine says C832. It doesn't say A832. So I then had to go searching for drivers specifically for the 8832CU version of this device. Now this took me down something of a rabbit hole, where I eventually found out this statement here, that the 8832CU is a variant of the RTW8852CU. And if I then looked up RTW8852CU on GitHub, I eventually found this link here. And I found that these drivers actually worked quite well. Now, as I mentioned earlier, depending on which type of Wi-Fi 6 USB dongle you have, the chipset may well vary. But if you have one that's built around a Realtek 8832 or 8852 chipset, these drivers should work just fine. And I'll put a link to this GitHub in the description below. So now I've found some drivers, I've jumped back here onto my Raspberry Pi. Now before I do anything else, what I'm going to do is update it with all of the latest software. And you can easily do that with sudo apt update and sudo apt upgrade -y. Now everything's installed, I'm just going to reboot in order to ensure that all of this new software is loaded. Now that everything's rebooted, we can think about building this driver code. But because it will be building a module for our Linux kernel, I'm going to need to install the Raspberry Pi kernel source code for my specific kernel version. Now fortunately, some bright spark has come up with a really nice, easy way to do this. And again, I'll link to this code within the description. It's just called rpi source, and it's a great little utility for grabbing all of this. Within the README for rpi source, it's got all of the installation instructions that you'll need. All you need to do copy this command here that will install all of the dependencies, and then we can go ahead and run this other command. So here, I'm just going to paste in that first command and confirm that I want to install it. Now that's all installed, I can go back and grab the second command here, come back to my terminal window and paste that in, and then run it. And returning back to the browser, now we can see all we have to do is run rpy-source. And that's exactly what I'm doing here. It'll take a few minutes to run, so again, I'll come back when it's done. Now that's complete, we can go ahead and actually grab the driver source code. Back on the driver GitHub, all you have to do is drop down the code button here and copy the URL shown here. Then you can move back to your terminal and type git clone and then paste in the URL to that repository. And that's pulled all of the source code for the driver onto our local file system. Now there is one slight issue here. If I run the command uname-r, we can see that we're running a version of kernel 6.1. Now returning to the GitHub driver page, when I looked at the history, I found that changes have been made to the source code to support kernel 6.7 and 6.9 and above, which is a perfectly reasonable thing to do. The problem is it stopped the build working for kernel 6.1. So to work around that, we want to use this specific version here, because that was made before all of the other upgrades to kernel 6.7. So what I can do is just copy this link here, move into the directory of all of our source code, and then I can say git checkout, and then I can just paste in that big ID that we just copied. And this will now switch us to that specific version of the code base. And now we're ready to build everything. And you can do that, make -J3, then all in capitals arch equals, and then back in lowercase, ARM64, and then just hit enter. That'll actually start the process for building these drivers. Now on a Pi 4 here, it takes around 6 minutes to complete. So I'll come back when that's done. Now the drivers are all built, I can install them with the command sudo make install. And now the drivers are installed. It's not been loaded yet, but we can do that easily enough. Returning to my dual window here. Again, on the right, I'm just showing the output from the dmesg --follow command. And on the left, you can see that we still don't have our new wireless network device yet. However, I can now load our new driver with the command sudo modprobe 8852cu. And you can see on the right that the driver has been registered and now a new device has appeared. So if I rerun IP link show, we now have our new WLAN1 wireless device. And this is our Wi-Fi 6E USB dongle. Now these are the settings on my router for my 6G wireless network. Now for any hackers out there, the password isn't going to be set to something as useless as this for very long. So don't get any ideas. But in theory, I should be able to see this network now on my Raspberry Pi with this command here, sudo iw-dev wlan1 scan, and then I'm piping the output from that into a tool called grep, which is a tool that just matches against strings that you give it. So if any result from the scan command comes back that includes the string pits_6g, it'll show up. Otherwise, it won't show me anything. Let's see if it brings anything back. And no, it hasn't. And why is that? We know the driver's loaded, and indeed we've got our device. So why can't it see our network? Well, we can get some idea if we look at the physical characteristics of the device that we can do with sudo iw-phy1 info. Now this gives me a whole bunch of information about my network adapter, but one thing that you can find in here is a list of supported frequencies. Now everything that you can see here are the list of 6G frequencies you can tell from the 6000 megahertz range, but they're all disabled. So why is this? The reason for this becomes clear if I run sudo iw phy1 reg get. Now here, the country is listed as unknown. And what does this mean? Well, in different countries around the world, they allow you to use different radio frequencies for wireless networks. They're not all supported in every country. And this 6 MHz band seems to be particularly protected. And I am wondering if this is why you're not finding the drivers baked straight into the kernel. I don't know that for sure, but it's just a suspicion I have. However, we can work around this. We've just got to give our driver some parameters to let it know what country we're in. But how do you go about that? Well, the first thing we need to know is what parameters are available to us. You can find that out by running sudo mod info and then the name of our module, in our case 8852CU. And here it tells us all of the different parameters that we can set for our network card. Now this one right here, rtw_country_code, is the one we're looking for. We can use this to set the country code within the driver to represent our country, and this will then unlock its support for particular radio frequencies. To do this, we need to create a configuration file for our driver. You can do that with sudo vi/etc/modprobe.d/8852cu.conf. Now I'm using vi here as my editor, but if you want to use nano or anything else, please feel free. And in here, I just need to put in this line, options, then the name of our module, so 8852CU, the name of the parameter, rtw_country_code, equals, and then your country's name. In my case, you can probably tell from the accent, GB. And then just save out the file. I now need to reload our driver in order to get that new parameter read in. So the first thing I'm going to do is remove it, which I do with sudo rmmod 8852cu. That unloads the device, and indeed, if I run ip-link show again, our WLAN1 device is now gone. But I can reload it with sudo modprobe 8852cu, and that has now reloaded the driver, and our WLAN1 device is available again. Now, one slight downside of reloading the driver like that is that our physical ID for our device has now changed. It's now PHY2 rather than PHY1. But if I run the command again to check its country, you can see now it is set as GB. And if I rerun the info command to get all of the information about this physical interface, now you can see there's a whole bunch of frequencies that are unlocked. They're no longer disabled. So now the country's configured. If I rerun the command to look for our wireless network, we can see it now shows up in the scan. So great, we can connect to it, right? Well, no, you can't. There's one more stumbling block, and that's the fact that Wi-Fi 6 networks use a different authentication scheme compared to Wi-Fi 5. And there's another configuration file we need to create to support that. Now, the Raspberry Pi on this particular version of the operating system uses some software called WPA_supplicant to manage its wireless network connections. We can create a special config file for our WLAN1 device by creating a file using the command sudo vi/etc/wpa_supplicant/wpa_supplicant-wlan1.conf. And you want to paste in this information here. I'll put this information into the description below so you can copy and paste it from there, but change the relevant information for your particular network. The first line here just describes how WPA supplicant maintains its metadata about the connection. It then says that we want to update the configuration, and then this funky line here tells it to use the Wi-Fi 6 authentication scheme, and typically that's WPA3. We then give it our network information. So the SSID is the name of your wireless network, PSK specifies your password, key management equals SAE is basically getting us to use this WPA3 personal way to store and encrypt the passwords. And we also need this final line of the IEEE 802.11w equals 2 line, again to make it use the right standard. Once you have this, just save it straight out. Now, one last gotcha before we can actually make all of this take effect is that if I run sudo apt list -- installed and I pipe the output into our grep tool looking for WPA supplicant, it shows that we've got version 2.9.0 installed. Now, the problem with version 2.9.0 is that it doesn't support WPA3. So we have to install a new version. Now, in order to get this new version, we need to give the apt system, which is the Raspberry Pi OS package management system, information about where it can grab the software from. So you do this by creating a config file with sudo vi/etc/apt/sources.list.d, and then you create a new file. I've called this Bullseye-Backports.list. The name isn't particularly important as long as you end with a .list extension. And then here I just want to paste in this line, deb, and the URL to the Debian repository where it can pick up the packages, Bullseye-Backports main. And again, I'll put this in the description below so that you can just copy paste out of there. Then just save out this file. Now you need to make apt update its list of repositories so that it looks in this new repository for packages. And you do that with sudo apt update. And finally, we can install our update with sudo apt install WPA supplicant /bullseye-backports. And now, if I rerun that command to show us the version of WPA supplicant that's installed, we can now see that it says version 2.10. And this has all of the support for Wi-Fi 6 that we need. So now I'm just going to reboot. Now I'm rebooted. Not only can we see our device, but if I run IP add show to show us IP addresses, we can see that the WLAN 1 device has now connected to our Wi-Fi 6 network and has an IP address. So finally, we're connected successfully. We've got our connection and that's great, but how well does it perform? Well, I've got another Raspberry Pi connected to my router via a wired cable. Unfortunately, I don't have a second device on my network that's using Wi-Fi 6 right now. But I should be able to see that other Raspberry Pi at roughly gigabit speeds, because that's the top limit of my wired network. Unfortunately, I haven't upgraded to 2.5 gigabit networking yet, let alone 10. But let's see how well iPerf3 does. So here I'm using the -B option to force iPerf3 to use the IP address of my Wi-Fi 6 connection. And here you can see that the bitrate is right up there. It's well over 800 megabits a second, sometimes getting into the 900s. And this is just depending on where your device is away from your router. Obviously, the further away it is, the performance will degrade. But let's see how this compares to our Wi-Fi 5G connection. So here I've just updated the command to use the source IP as our Wi-Fi 5G connection. And as you can see, the bitrate is kind of 10 times slower. So our Wi-Fi 6 connection is actually looking really, really good. Very solid, very, very fast. Now, as Jeff Geerling proved when he did a similar thing using a PCI Wi-Fi 6 adapter, he's got 2.5 gigabit networking running at his place, and he was able to see the Wi-Fi 6 speeds get around 1.5 gigabits per second. And that's a great result. So with the USB adapter, if I had 2.5 gigabit networking, I'd expect to see a similar level of performance. So there you have it. We've got our USB Wi-Fi 6 adapter running perfectly fine on a Raspberry Pi, but it's been extremely painful getting there. And this is one place where I find it incredibly frustrating with Raspberry Pi OS and Linux operating systems in general, that there isn't support for such things as Wi-Fi 6 just built into the kernel, at least not yet. Now on my laptop, if I booted that into Windows and I plugged in my Wi-Fi 6 adapter, it would just work straight away. And here we are in 2024, or maybe later, depending on when you're watching this video. And yet in the Linux kernel, there isn't this native support yet. Well, okay, maybe it is if you're watching this in 2025 or 2026. But certainly right now, there isn't. And I've had to jump through all of these hoops with the driver, with WPA supplicant, with setting the country information for the driver. I've had to do all of this myself. It's not been a pleasant experience at all. The end result is great, but it's not been good getting there. So all I can ask is that the kernel developers for Raspberry Pi and other Linux implementations start getting Wi-Fi 6 included within the kernel. That way, everything will just become plug and play. You could just plug in your USB adapter and the drivers would just be there waiting for it. But that's it for this video. Once again, if you liked what you see here, please hit that like button, subscribe to see more, and hit that notification bell so you can be told when I put new videos out. Let me know in the comments how you get on with your Wi-Fi 6 adapters, especially if you're using different chipsets and you really have to go hunting for the drivers. And if you've got any other ideas for other projects you'd like to see me do in the future, put those in there as well. Thanks so much for watching till the end, and until next time, bye for now.